In this video, we'll take a look at this statement, decide if it's true or false, and then make an argument. If the statement is true, we'll explain why. If the statement is false, we'll provide a counterexample with an explanation. The statement is, suppose f is defined on a closed interval from -1 to 3. If u is any number in between f of -1 and f of 3, then there's at least one number c in this interval such that f of c equals u. Now, hopefully, this seems familiar. This should sound like the intermediate value theorem. So one way to make these problems easier is to recognize a similarity to a known theorem and then figure out what's different. And in this case, we have a key word here, defined. The intermediate value theorem has continuous here. And so this will give us an insight onto how we can find a counterexample to show that this statement is false. It's a good idea to draw pictures to make sure you can do this, and then you need to make sure you clearly define all of the pieces. So your picture and your example needs to work on the interval. We need to make sure we define f of 1 and f of 3 and do all these pieces. Okay, so I'm going to start by drawing a graph. And I know that I need to include x equals -1 and I need to include x equals 3. So I'll put those on there. And then I'm going to have an f of -1 and an f of 3. So I'll add those to the graph as well. Notice I haven't come up with what my function looks like yet. I'm just drawing kind of the pieces. So we have our interval, we have f of 1, we have f of 3. U needs to be some number in between f of 1 and f of 3. So maybe we'll go ahead and define u to be here. U is an output value, so it should be on the output axis. And now, if this statement is false, basically what I'm saying is my function never touches that value. So now I can come back in and fill in my function and just make sure I never touch that value. I do need to make sure my function is defined for all x values, so I can't have any places where there are x's where there's no y's, but I can definitely do something like this and something like this. And then I want to make sure that I talk about what's going on here. If I draw this example, then I have not satisfied all of the conditions because my function is not defined for this input. But if I simply fill in this circle, either one, now my function is defined on the closed interval. U is a value in between f of -1 and f of 3, but there is no input that I can plug into my function and have the output equal u. So I would say this statement is false. My function f of x is pictured here. I can say that f is defined on my interval -1 to 3. I can say that f of -1 is less than u is less than f of 3. So I'm showing that my u value is in between f of -1 and f of 3. And then I would conclude saying there is no value for c in the requested interval from -1 to 3, so that f of c equals u.